So let us see now how do we use the Napier rule and how do we calculate these intermediate positions.
Sir.
Okay, all right.
Why do we need these intermediate waypoint positions? This is because our GC track crosses meridians at different angles. Therefore, if you want to sail precisely over a GC track, the course has to be continuously altered, which is not very practical. So along the great circle track, suitable intermediate waypoint positions are picked up, and between the waypoint positions, vessel does rhumb line sailing. So by doing so, you approximate the GC track to the extent possible, and at the same time meeting the requirement of the vessel to be sailing along stretches of rhumb line. Another application of the vertex could be in composite sailing, which shall be covered in the next video. Now, when it comes to calculating or obtaining the intermediate waypoint positions, there can be two ways of approaching it, depending on the suitability of the track. One is we decide on the latitude on which we would like to have the waypoint and where this parallel of latitude would cut the GC track. For that point, we need to calculate the longitude. Other way could be we decide on the longitude. So wherever the meridian of that longitude cuts the GC track, we calculate the latitude of that point. This can be conveniently done by factoring in vertex because it shall result into right-angled spherical triangle and Napier's rule can be applied. Now, in the first scenario, wherein we may have decided on the latitude of the intermediate waypoint.
So beta, now we are going to discuss the first type in which they have given us a certain latitude and they want us to find out what is the position where the great circle track crosses that particular latitude. So this is the first type. Latitude is given and we need to know the position where the great circle track crosses that latitude. So first of all, we will find out the vertex. As we have seen earlier, we will see where does the vertex lie, then we will make a diagram, and then in that diagram we will apply the Napier's rule and find out the latitude and longitude of the vertex. So in this example, I have assumed that the vertex lies inside the triangle. So it can be solved with vertex lying outside also. So the method is exactly the same. So they will give us one particular latitude and we need to know or find out what is the position where great circle track crosses that latitude.
We can just draw the parallel of latitude that we have decided upon. Wherever this parallel of latitude crosses our GC track, this is the waypoint that we are interested in.
So beta, this dotted line which you see is the latitude which is given to us, and we need to find out what is the position, what is the place where great circle track crosses this particular parallel. So this position you can call it as X.
Let's mark it with X.
Now can you tell me beta, what will be the latitude of X?
Latitude given sir.
सर कुछ डिलेट दिया होगा ना सर?
Right.
तो डिलेट होगा A और X का.
Right. So either they will give you a DLAT or they will tell you find out where the great circle track crosses a particular latitude, let us say 20 degrees north. So whatever latitude is given, our position X has to be on that latitude only. So latitude of X is in fact already known to us. It is the latitude which is given. What we need to find out is the longitude of this position. So let us see how do we find the longitude now.
So the latitude of X is already known to us. We need to find its longitude. We draw the meridian of X and we get a right-angled triangle PVX, in which from the latitude of the vertex, we know PV From the latitude of x, we know px.
Now, beta, do you see this triangle PVX?
Yes, sir.
Yes, sir.
Now, this is a right-angled triangle. The right angle is at the position of the vertex. Here is where we have the right angle. And in this triangle, that means we can apply the Napier's rule here. So in this triangle, do we know two things at least? कोई दो
Yes,
चीजें
sir.
हैं बेटा जो हमें पता है कौन कौन सी?
Yes, sir.
Yeah. PV
The
and
polar distance
PX.
पता है sir. PV and PX.
Very good beta.
Oh,
So
sir.
two things which are known to us are number one, we know PV, this particular distance, Papa to Victor.
Yes, sir. PV also known.
We had calculated the latitude of the vertex. So with the latitude, we know what will be PV. PV is the colat of the vertex. And the second thing which we know in this triangle is PX. PX is
Collet
known
of
to us.
X.
It will be the colat of position X or colat of the latitude which is given to us. So whatever latitude is given to us where we have to find the intermediate position, colat of that will give us Px. So once these two are known to us and it's a special spherical triangle, we can apply the Napier's rule and find out anything else. So let's see how do we apply the Napier rule now.
So the elements that are known to us are px and pv. If we can calculate angle p, which will be the d long between v and x, then that shall help us in getting the longitude of x.
So what we do beta with these two items, Papa Victor and Papa X-ray, we enter into the Napier's rule, and what do we calculate with the Napier's rule is angle P.
Angle P.
So once angle P is calculated, what will be this angle P beta? What is this angle P?
D long sir. D long हो जाएगा sir. फिर कर
Very
सकते हैं
good.
हम longitude से calculate.
Very good beta. It will be the D long between the vertex and the position which we require. So once we have this D long known to us, we apply it to the longitude of the vertex. By applying, I means it could be added or subtracted depending upon what is the name of the longitude and what is the direction of the D long. So once we apply this D long to the longitude of the vertex, we will come to know what is the longitude of our required position X. So is this clear beta up to here?
Yes, sir.
Okay, very good.
In the second scenario, we could have the longitude of the waypoint pre-decided. So what we can do is we can draw the meridian of the waypoint.
So now beta, in the second type of the problem, instead of giving you a parallel of latitude, what they will give you is a longitude or a meridian, and you have to find out where does the great circle track crosses that meridian. So now what we do is we draw that particular meridian from the pole going downwards like this. We draw this particular meridian.
And wherever the meridian of the waypoint crosses the GC track, which is this point, this becomes our waypoint and we can mark it with X.
So we have our X point here now. Now again beta we have a triangle PVX, Papa Victor X-ray. Is this a spherical triangle?
Yes, sir. This is spherical triangle, sir.
Yes, the
This is
right
a
angle spherical
spherical
triangle.
as well as a right angle. That means a special spherical triangle. And that means we can apply the Napier's rule here. So in this case, beta, with this longitude of X given to us, uh, do we have two items which are available to us in this triangle?
Yes, sir.
Yes, sir.
The
Okay,
angle is known and the arc one
And
side is known.
and PV.
PV and angle P.
very good, beta. So PV was known to us earlier because we found out the position of the vertex. PV is the colat of the vertex. So PV is known to you. And the second thing which is known to you is this angle, angle P. This angle P is the D long between the vertex and the required position. The longitude of the vertex was already calculated, so we know that, and the longitude of x is given in the question. So we find out the d long between these two positions and apply it to the longitude of the the d long is known. We enter into the Napier rule with PV and d long, and what do we calculate now? We calculate side PX, Papa X-ray. So with angle P and side PV, we enter into the Napier rule and solve it or solve the triangle for side PX, Papa X-ray. Now once you get PX, we know PX is the colat of position X. 90 minus PX gives us the latitude of X.
Now, because the longitude of V and longitude of X is known, we can calculate this D long P here. PV is also known to us by virtue of knowing the latitude of vertex. So we know the PV part of the right angle triangle. We know angle P of the triangle. We can solve it for PX, which will be colat of X, from wherein latitude of X can be obtained. So here parts known are PV and P. To be calculated is Px.
So beta, with this we complete this type 2 problem also, where a longitude is given to us and we need to know what is the position at which the great circle track crosses that particular longitude or meridian. So this is the type 2 problem. So now beta, in the great circle questions, this is what will be given to you. They will give you either a particular latitude or a particular longitude, and they will tell you to find out the position where great circle track crosses it. So we have to first find out the vertex. Once vertex is known, we have to make this diagram and find out that position X. So any doubt in your mind related to this complete process now?
Sir, this angle P is the D long. And sir, naming will be take from the vertex longitude or the direction of the vessel of
Okay,
D long.
beta. Let's take an example. In this particular case, give me any longitude for the vertex, any longitude.
Okay, sir, 50 degree east.
Okay, so vertex is at 50 degrees east longitude. We know that, we have already calculated it. So this comes to be 50 degrees east. Now give me this angle P beta, any angle P of your liking.
35 degree.
Okay, this angle P is 35 degrees. We applied the Napier rule, it came to 35 degrees. Now longitude of the vertex is 50 degrees east. The D long between V and X is 35 degrees, and we know this position X is on the left side of the vertex, which means it is to the west of the vertex. So this 35 degree D long is westerly D long. So
Westerly. Okay,
from
sir.
50 degree east, you go west by 35 degrees and you will reach here as 15 degrees east. So 50 degrees से 35 degrees हम लोग west में गए and we came to 15 degrees. So longitude of X would be 15 degrees.